to find the time, definitely I have to use s equals ut plus half at squared, this relation. Which direction I am going to use this? You can use any direction, right? You can use any direction, upwards or downwards. But here last time I used downwards, so this time I use upwards. Then you will learn how to apply that one also for the upwards also. So now this is something that you have to be careful. Instead of s, I am going to take 60, but we always apply the equation from this level. So if something measured from here to upwards, right? If something measured from here to upwards, we take it as positive. We take it as positive. This side is positive, right? Because I have told that I am applying my equation upwards. So once I said like that, it means everything measured from starting point to upwards direction, I have to take positive. But if something acting from here to other direction, then that one is not positive, it is negative. So the first thing that you have to understand, you are measuring from this level because that is the starting point. Starting point also is on that level. So since I have put my arrow to the upward direction, when I measure the displacement from this level to the upwards, I have to put it positive. If I measure the displacement from this level to downwards, I have to take it as negative. So here I am measuring the 60 from here to downwards. It means negative side. Therefore, I have to put here not plus 60. I have to put there negative 60. Negative 60. It's equals. Now I have to take the velocity component. So it's given here like 5. And 5 is acting upwards. I'm using my equation also upwards. Therefore, I'm not going to change the number, change the sign. I just write plus 5. No need of writing plus there, right? So just 5. So it means that's plus 5. And the time that I'm going to find, so I just put just t. Then half. This half I have to put there. I'll put it here, half. Now the acceleration, what I'm going to take as the acceleration? Acceleration is gravitational acceleration. The gravitational acceleration is always acting downwards. It is acting towards the ground, gravitational acceleration. So it's negative again because it's downwards. So I have to put a bracket and minus 10. So I hope that you understood why I put minus sign, because it is acting downwards and I'm applying my equation upwards. So then t squared, I have to put there squared. You know, when you do the sum for the exam, you write this equation and after substitute these values properly with directions, you are getting marks for that. So at the same time, you will understand if you don't put like that, you are losing the marks also. Right. Then we are going to simplify this. So I can write this minus 60 as it is, minus 60 equals 5t minus this 2 and this one, it cancel and become 5 and t, so squared, t squared. Now, so look here, 5 here, 6 here, so I can divide everything by 5. Right? I like doing that because then my sum becomes simple. Five from here and another five. So you can easily cut them. Cut, 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 cut. And here you get minus 12. So final answer is final, not final answer. After simplified, we get minus 12 equals t minus t squared. Oh my god, this is a quadratic equation. So when you get a quadratic equation, we can't just straight subject t. Therefore, we are trying to factorize this. If it is not going to be factorized properly, you are in a bad luck. But I don't think here we face that problem. So I moved this t squared other side because we know when we are going to solve these kinds of quadratic equations, we have to make all the terms to other side, leaving the next side 0 and factorize. So I move this minus t squared this side, so then it becomes t squared minus t, because this t, when it moves to other side, it becomes minus t, minus 12 equal 0. So it's a really simple quadratic equation that we did in our O levels. Here, when I'm going to factorize this, I'm getting two answers. One is like t minus 4 close to bracket and t plus 3, t plus 3 bracket equal 0. So this is what I get. So then here I'm getting two answers. One is like t minus 4 0. That's one answer. Other thing, t plus 3 equals to 0. T So there are two answers. So I am getting t equals 4 and t equals minus 3. T equals 4 and t equals minus 3. So the t is time. Now, when I'm going to think that t equals minus 3, there's some practical issue, right? Because time cannot be a negative value. Since time cannot be a negative value, we are not going to take that. Now you have a question. If you are not going to take it, why it came to this equation? I can explain this like this. We are starting to measure from here. From here to here, it takes 4 seconds. If it comes from here to here, right? If it comes from here to here, it would have taken another 3 seconds. Understood? So if it comes from here to here, it takes 3 seconds. Then after that time only we are getting. So this is practically doesn't happen because we know we are not using any time travel to go past. So it's not happening like that. So we are not going to take t equals minus 3 part. So once we get like that, we better say it's not equal. Wait. So only the answer is t equals 4 seconds. 4 seconds.